So you got an integral and you've tried algebraic techniques, you've tried u-sub, but you realize that you can't do anything with the integral. So that's where this comes in. So you can't simplify your already complex integral with your algebra or u-sub techniques. That's probably a high chance, there's probably a high chance that it solves using integration by parts, and that's what I'm going to teach you guys. So this right here is basically going to be the formula for integration by parts, and I don't want you to focus on this formula. Just give me a sec. So I have this integral over here. Now integration by parts works in the following way. You have these this thing over here, this thing. This is called the integrand. And what you're trying to do is you're trying to see a part of the integrand that is easy to differentiate and a part of the integrand that is easy to integrate. But you can go ahead and be like, okay, what if they're both easy to integrate or they're both easy to differentiate? What do I do then? Well, then you're trying to look for something that is meaningful, right? So if I choose x over here, let's say I go ahead and I say I'm going to integrate x. What happens when I do that? Well, if I keep on integrating x, I know it's due to the power rule, it's going to go x squared and then x to the power 3 and then x to the power 4. It's going to keep on getting more and more complex. I don't want that. I want to simplify things. Remember, the purpose of using integration techniques is to simplify integrals, not make them more complex. So if I integrate x, I know using the power rule, it's just going to become x to the power 2, x to the power 3, x to the power 4. I don't want to do that. What if I differentiate this? So I know if I differentiate the x, it's just going to become 1. Now that right there is useful because now I've simplified the x into a constant. I've simplified it into 1. Okay, what about e? What happens if I integrate e? So if I integrate e, I know e to the power x integrates to e to the power x, and e to the power x differentiates to e to the power x. So it really doesn't do anything too special. But looking at that x, what I do know is that if I differentiate that x, that x is going to get simpler. It's going to turn into a 1. So that's what I'm going to be differentiating. I'm going to be differentiating that x, differentiating the x. And then the e to the x, well, it doesn't really do anything special. I know if I integrate or differentiate this, it's not going to do anything special. But since I know that I'm differentiating x, now what am I going to do with e to the power 2x? Well, I'm just going to have to integrate that one. So you can't differentiate both of them, or you can't integrate both of them. One needs to be differentiated, the other needs to be integrated. Okay, so that's the first part of integration by parts. Now, once you've decided that, then I want you guys to come to this formula right over here. So you see there's an integral that has the parts f of x, and it has a part g of x dx. My bad, this is a g prime. So what happens is this g prime is when I integrate it, it basically becomes just a g, right? And this f of x, what happens when I differentiate it? When I differentiate this f of x, I know it's going to become an f prime of x. Looking at our integral, what is going to be f of x and what is going to be g prime of x? Well, what am I differentiating? I'm differentiating the x. So that is just going to be f of x, okay? And then when I differentiate it, it's going to become f prime of x. And this part, since I'm integrating it, I can say this is g prime of x, and when I integrate it, it's going to become g. So an easy way to remember this is whatever you differentiate becomes your f of x, and whatever you integrate becomes your g prime of x. That's an easy way to remember it. Okay, so we've done good so far. Now what? Well, now all you got to do is you got to write f of x. I know that is x since that is what I selected. And then what is going to be f prime of x? So the f prime of x is going to be just 1, because when you differentiate x, it just becomes 1. Okay, now what is g prime of x? Now I know g prime of x is basically e to the power 2x. So what is going to be g of x? Well, you'll have to integrate. So what is the integration of e to the power 2x dx? Well, this is where it gets a little tricky, and this isn't a simple integral, it's a complex integral. And so you have to apply some technique on it, and you can't apply algebra. It's really obvious when you look at this integral. There's no algebraic technique you can use to simplify this. So what do? Well, you think about u-sub. Well, I can't apply u-sub on this. Yeah, I can use u-sub. I can make this my u, and is the differentiation of u present outside? Well, the differentiation of u is going to be 2, because 2x is going to differentiate to 2. 2 is a number, it doesn't matter if it's present outside or not. So you can integrate this, and this thing is basically going to become e to the power 2x divided by 2, right? I'm not going to do that for you. And then you can go ahead and write that over there. Okay, now you can go on and just apply this formula. So that's going to be f of x times g of x. I know what my f of x is. It's x. So it's f of x times g of x. This is my g of x. That is e to the power 2x divided by 2. And then it's subtracted by, you add that integral sign, it's f prime of x. That was 1 times g of x. So g of x is basically this thing, e to the power 2x over 2. Okay, so I can and of course, don't forget your dx. And that plus c is still there, so of course we're going to have that plus c. So what happens over here? Well, I have this constant. I need to first of all solve this integral. So I have this constant 1 by 2. I can go ahead and pop that out of this integral. So that is going to be 1 by 2. Okay, now I just got this thing. And if it's still a complex integral. It's not a simple integral. And I don't need to solve this again. Why? Because I already solved it up here. So this e to the power 2x, I know what it integrates to. It integrates to this thing. So I'm just going to chuck that thing in here. And just like that, you have completed your integration by parts. Now you can finish this or simplify this, and basically it's going to become, and that right there is the answer to your initial integral. So I got some practice integrals over here, and I'm basically going to be doing these. So I have my x to the power 4 cosine x dx. Now again, I need to find something that simplifies when I differentiate and something that simplifies when I integrate. So you think about this cos. What happens when I integrate or differentiate cos? Well, if I integrate it, this is going to become sine of x. And then if I differentiate it, it's going to become negative sine of x. And then what happens when I integrate or differentiate these two things? Well, it doesn't matter. They'll just keep on alternating. So cos will keep on alternating to sine, and then sine will alternate back, and that's just a cycle. So they don't really do anything too special over here. So I'm just going to erase all of that. They don't do anything too special. What about this x to the power 4? What happens when I integrate or differentiate this? So if I integrate this, I know the power is going to keep on adding up. What if I differentiate this? So I know the power is going to decrease. It's going to go 3, 2, 1, and then 0, and then it's going to become a constant eventually. It's going to add this x to the power 4. It's going to become a constant. So this seems more useful to me. Differentiating x to the power 4 seems more useful to me. So I am going to be differentiating this thing right over here. Now, the thing I differentiate, I go ahead and call that my f of x. And so, of course, if I'm differentiating this, I need to be integrating the cosine. So this is what I'm going to call my g prime of x. And now I can just go ahead and apply the formula. But before that, I'm going to write my f of x over here. And my f of x is equal to x to the power 4. And my f prime of x is going to be equal to 4x to the power 3. And then I'm going to have my g prime of x, which is cosine x. And if I integrate it, I know that the integration of cosine x makes it sine x. So now you can just go ahead and apply the simple formula. And so that is going to be f of x times g of x. So that is x to the power 4, x to the power 4 times sine x, right? And then subtract the integral of f prime of x, which is 4x to the power 3, times g of x. So that's that thing right over there. Okay, so I just end up with another integral. What do I do now? Well, you take a good look at this thing. You realize how you can solve this integral. It's clearly not a simple integral or a general integral. It's definitely complex. So how are you going to solve this? Well, you're going to apply your techniques. And you've got your algebraic techniques so far. You've got your u-sub techniques, all this bros party together. Remember that? So you're clearly not going to be able to apply algebra on this. There's no algebra you can do on this. Be free to think about it. There's no u-sub you can do on this thing. So then that leaves by parts. But you're like, oh, I just did by parts. Now I got to do by parts again? Yes, and you're going to come across questions like these a lot. So I'm going to do by parts on this again. So I have my same strategy. I know if I differentiate this x to the power 3, I know it's going to keep on getting simpler and simpler and simpler. So I'm going to stick to that. I'm going to differentiate this. And so this is what I'm going to integrate. This really doesn't matter. The sign really doesn't matter that much because it's just going to keep on alternating sine, cos, sine, cos, sine, cos. Okay, so I got my f of x. And I got, and just to make this a little more simple, actually, never mind. So f of x is going to be 4x3, and then f prime of x is going to be 12x2. And then my g prime of x is sine x, and my g of x is going to be, I believe it's going to be negative cosine. I hope I'm not wrong. Negative cosine of x. Okay, so I integrate this once more. And what I'm going to do is I'm just going to ignore this right over here for a bit, and I'm going to focus on just this integral. So this is what I'm solving. I'm just solving the integral on this side. So the integral is going to solve out to f of x times g of x. So that is going to be 4x3, and that's going to be negative cosine x. And then I subtract another integral, and that is going to be f prime of x, which is 12x squared, times g of x, which is going to be negative cosine of x dx. So this is going to be negative 4x3 cosine x. I can grab that 12 outside, so that's just going to become that negative 12 outside. So that's going to become positive 12x squared. And actually, you know what? I'm just going to keep that x. I'm going to keep that 12 inside. I'm going to grab those negatives out, keep that 12 inside, and so I'm going to have this thing right over here. Okay, now I got to do integration by parts again. But before I do that, what I'm going to do is I know this thing is the answer to this thing. So I'm going to join all of this, okay? Just to make it a little simpler. So this is going to be x to the power 4 sine x, then negative, and that integral gave me this part, negative 4x3 cosine x, and then positive 12x squared cosine x dx. Okay, so I'm just going to solve that out. That is going to be x to the power 4 sine x, positive 4x3 cosine x, and that is going to be negative integral 12x squared cosine x dx. Okay, so I gotta solve this thing now. And you can go ahead and apply your techniques on this, algebraic techniques, your u-sub techniques. This is not going to solve. So you'll have to apply by parts on this as well. And I have the same strategy. I did know that this was going to be a problematic integral. So that's why I decided to reduce the power of that x. And so that is going to be my f of x in this case as well. That is going to be 12x squared. F prime of x is going to therefore be 24x. And then g prime of x is going to be cosine of x. And then gx is going to be sine x. And I'm going to ignore all of this, and I'm going to integrate that 12x squared cosine x. And so that is going to be f of x times g of x. So that's 12x squared times sine x, subtracted by integral f prime of x, which is 24x, g of x. So that's going to be sine x. And then again, I'm left with another integral that I'll have to apply by parts on. But before I do that, I'm going to chuck all of this back where it belongs, because I don't do that and then I forget doing that. I'm just going to make some space over here. Right, so we have x to the power 4 sine x plus 4x cubed cosine x, and then we got negative, and then that right there is 12x squared sine x minus, and I believe so that I'll have to remove all of these things as well. So if I could, right, so that is going to be 12x squared sine x minus the integral of 24x sine x dx. And this negative is going to go ahead and multiply inside, so this is going to be x to the power 4 sine x plus 4x to the power 3 cosine x negative 12x squared sine x positive 24x sine x dx. Okay, now I believe this is going to be the final time I will be doing by parts on this. So that right there is something I cannot solve using my other techniques, and so I'm going to apply by parts on it. And so what is going to be my f of x? It's going to be the same. It's going to be the term with the x. So this is going to be 24x, and I know that the differentiation of this is just going to get me that 24. And then I'm going to have my g prime of x, which is my sine x, and then my g of x is just going to be my cosine, my negative cosine x. Okay, so now I solve this. And if I solve this, I'm basically going to get that integral is going to be f of x times g of x. And then it's going to be minus f prime of x, which is 24, is negative cosine x dx. Right, so that I can simplify, take that negative 1 out over there, so that's going to be 24x cosine of x positive 24 cosine of x dx. And this integral right here, this is actually a general integral, so I can solve it without using any techniques. And so this is going to be 24x cosine of x plus 24, and that cosine x is just going to become sine x dx. Okay, that's my final answer. I don't have any more integrals, so I can go ahead, chuck that final answer into that part right over there. So that's what I'm going to do. I'm just making some room over here. So that right there is the final answer to this nasty integral right over here. And of course, don't forget your plus c at the end, right? That plus c is obviously necessary because this integral right over here was an indefinite integral, did not have any limits, so that plus c is necessary in the final answer.